All right, hey everyone, this is Cody. I apologize for my absence today. Um, I hopefully will be back on Wednesday. I'm feeling better so far. In preparation for tomorrow's class, I'm going to be working with a sub. I wanted to go over some of the stuff we would have covered in class today, and then also, yeah, teach you guys some of the stuff we were going to talk about so that you're prepared to work with the sub tomorrow, and then also be ready for Wednesday's quiz. Okay. So the first thing I want to talk about is horizontal asymptotes, finding those for a rational function. Now we started looking at this on Friday, and I just want to take this a step further. So up here I have the three functions that were on our slides. Okay, so n of x is x cubed minus 3x over x squared minus 6, 3x cubed minus 4x plus 5 over 6 minus 2x cubed, and then 6x plus 4 over x plus 3 times x minus 5. Now, in each case, we find or determine the horizontal asymptote by looking at the ratios of the leading terms. Okay, or first of all, we look at how the leading terms compare and then use those. So, for the first one, note that we have an x cubed on top and x squared on the bottom. Okay, and in this case, this is a case where the power on the top is larger than the power on the bottom. Okay, so that's a case where we end up with what's called a slant asymptote. So if you remember from the graph of this function, it maybe didn't look like it had a horizontal asymptote, but it looked like maybe if we drew a diagonal line through it, then that would give us an asymptote, and that's what we get here. So because the degree on the top is higher than the degree on the bottom, we have the slant asymptote, which another term you'll hear used for that is oblique asymptote. Okay. Now, there's a question on your homework that will ask you to find the equation of that slant asymptote, and I believe there's a video to help you with that, so you can follow that. I will tell you that for a test or a quiz, I am not concerned about you knowing how to find those. Okay, so just know that how to figure out whether a function has one, but don't worry about finding what it is. Okay, but that's only for the slant asymptotes. All right, let's look at the next one. So next one, s of x, we have 3x cubed minus 4x plus 5 over 6 minus 2x cubed. And you notice that in this case, the leading terms on both the top and the bottom have the same degree. Okay, we have a 3x cubed on the top, a negative 2x cubed on the bottom. Okay, and so because those powers are the same, or the degrees are the same on the top and the bottom, we can find the equation of our horizontal asymptote by doing the ratio of those leading coefficients, which are going to be the coefficients with those terms. Okay, so in this case, what we would have, our horizontal asymptote will have the equation y equals, on the top, our leading coefficient is a 3, so it's going to go on the top there, and then the bottom, the leading coefficient is a negative 2. We'll keep that sign with it. Okay, so we get that our equation of our horizontal asymptote is y equals negative 3 halves, or negative 1.5. Okay, so that's our equation there. All right, and that's what we do when the numerator and denominator have the same power, or same degree. Okay? All right, let's look at the bottom one here. So we have 6x plus 4 over x plus 3 times x minus 5. Now, again, we want to look at the leading terms, or the degrees on both the top and the bottom here. So on the top, I see that my leading term is 6x. On the bottom, when I do x times x, I know my leading term will become x squared. Okay, when I multiply all that out. And what I notice here now is that the degree on the top is lower than the degree on the bottom. So I have a first degree on the top, a second degree on the bottom. So when we have that, where the degree of the degree of the denominator is higher than the degree of the numerator, then our horizontal asymptote is always at y equals 0. Okay, so that's again whenever the degree of the denominator is bigger than the degree of the top. Now, I would suggest you go back and regraph all of these on your graphing calculators and check and see that, in fact, those are where all the asymptotes are. Okay? Cool. All right, let's look at some other stuff here. All right, so we're going to start graphing rational functions now, and we're going to do this by hand without our calculators, which is something you might be asked to do on Wednesday's quiz. Before we do that, though, I want to remind us about the graphs of the reciprocal and the reciprocal squared functions. Okay, so you hopefully recall that this is what these graphs look like. And if you remember, on the reciprocal function, it's got a vertical asymptote right here at x equals 0 along the vertical axis. And then the reciprocal squared function also has one at x equals 0 there along the vertical axis. And hopefully what you also notice about both of those is the directions the tails kind of go on each side. So notice on the reciprocal function, from the right the tail goes up, and from the left the tail goes down. On the reciprocal squared function, both tails go in the same direction. Okay, and what that's going to help us figure out is what happens at each of our asymptotes, vertical asymptotes, in a rational function. Okay, and what we're looking for is we know that the vertical asymptotes, their equations come from the denominator of the function, what makes the denominator 0. And then to determine what happens with the tails here, we need to look at the power of that term. So if it's odd, the tails on each side are going to behave like the reciprocal function. If it's even, they're going to behave like the reciprocal squared function. Okay, so we get things like that. So let me show you what that looks like. Okay, so here I have a rational function, 2x minus 3 times x plus 4 on the top, x minus 1 and x plus 3 on the bottom. So what we're going to do first is go through and identify all the different characteristics of this function, the asymptotes, the intercepts, and then use that to draw the graph, okay? I'm going to start with the vertical asymptotes. And if you remember, we figure that out, or figure out where they are, by looking at the denominator, right? And so here I see an x minus 1 and x plus 3. And so those two things will give us our vertical asymptotes. And we think about what makes each of those 0, right? So for x plus 3, we know it's made 0 at x equals negative 3. Okay, and x minus 1, we know that's 0 at x equals 1. All right? And this will become important later, but notice that both of those terms are raised to the first power. Okay? So because they're raised to the first power, we know that when we draw the graph, the tails on each side of them need to go in opposite directions. Okay? Let's also find our horizontal asymptotes. So as we just talked about, we need to find those by looking at our leading terms in the numerator and denominator. So up here, I see that I have a 2x times an x, which will give me 2x squared as my leading term up there. On the bottom, I'll do x times x, which will give me x squared. And so what I notice is I end up with the same power on the top and the bottom. So my horizontal asymptote is going to have the equation given by the ratios of their two leading terms. So here we see a leading term of 2. On the bottom, there's not any number there, so we know it'll be a 1. So we'll have 2 over 1. Okay, will give us our ratio for our horizontal asymptote. So in that case, we get y equals 2 over 1. Okay, so that will be our horizontal asymptote. We're now going to work on our intercepts. Okay, so start with the vertical intercepts. Okay, and as we've been talking about for the last few weeks, when you find a vertical intercept, you plug in 0 for your input, all right? So I'm going to do the same thing here. So I'm going to do f of 0. Okay, and I put 0 in everywhere there's an x, and so I'm going to do, to save space on my board and time for this video, do this quickly in my head. So I have negative 3 times 4 on the top, negative 12 over negative 1 times 3 on the bottom, which is negative 3. So that's negative 12 over negative 3, which gives me positive 4. So I know my vertical intercept happens at 0, 4. And next things I want to find are my horizontal intercepts. Okay, we've also been talking about this for the last few weeks. We know that we find horizontal intercepts by setting our outputs equal to 0, right? So the way we do that is we'll say 0 equals okay, so 0 equals our function. And then we got to think about how are we going to find out where these intercepts are, okay? Well, notice that we have a rational function over here, right? Because it's a ratio of two functions. Now let's think about how does a ratio, which a ratio is another word for a fraction, how does a ratio become equal to 0, right? Does it happen when 0 is in the denominator of that fraction? No, because we know that if there's 0 in the denominator, that's not allowed. We'd be dividing by 0. Does it happen when 0 is in the numerator? Yes, it does, right? Because we know if we have something like 0 over 4, that makes 0, right? Or if I have 0 over 1,000, that also makes 0, okay? So both of those things give us 0, okay? So what that tells us then is for our rational function to figure out where the horizontal intercepts are, we need to figure out what makes the numerator equal to 0, right? So here I have 2x minus 3 times x plus 4, so those are the two things on the top. I want to think about what makes those equal to 0. I could set each of them individually equal to 0, and I believe if I do that, what I'll end up with are 3/2 0 and negative 4 0 would be our two horizontal intercepts, okay? So those would be our two, horizontal intercepts there. Again, we looked at what made each of the top terms equal to 0. I also want us to notice that for each of those terms that those numbers came from, they have powers of 1. Okay, so 2x minus 3 is to the first power, x plus 4 is to the first power. And that's going to be important when we figure out what happens when the graph passes through those points, just like it did with polynomials. Okay? So now that we have all this information, we can go ahead and graph our function. I'm going to erase the stuff up above here. Okay, and draw my graph. Okay, and we're going to start here by graphing by putting in all of our asymptotes. So I know from right here, I have asymptotes at x equals negative 3 and x equals 1, or sorry, vertical asymptotes at those. So I'm going to add those to my picture. Okay, then I also know that I have a horizontal asymptote at y equals 2, so I'm going to put that in the picture. Okay, and then I'm also going to add in my intercepts. Okay, so I have a vertical intercept at 0, 4. And then horizontal intercepts at 3/2 0 and negative 4 0. Okay, and now we're going to use the asymptotes along with the information in the function as well as our intercepts to draw the picture. And when I do these, I like to work left to right. So I'm going to start on my leftmost point, which is right here at this horizontal intercept at -4, 0. Now, I see that there's a horizontal asymptote here at y equals 2. And you know that from that point, the graph is probably going to go up close to that asymptote. And then we know that in the long run, it gets closer and closer to it, but never passes it. So it probably is going to look something like this. Okay, so the graph going up, sloping up towards that asymptote and just kind of running below it. And then I also want to look in my function and see what happens at that 0. So when I look in the function, the x plus 4 is to the first power. Now if you think back to polynomials, when the term corresponding to a 0 is to the first power, what does that mean happens there? Oh, right, so the function just goes straight through, right? So we're going to see the same thing here. Go straight through and then run along that vertical asymptote because we know it can't cross that. Cool? All right, so let's go to the next side of the asymptote then. So here, so we see we have the vertical intercept here, so this part of the graph is going to have to go through here. Also, this vertical asymptote right here is at x equals -3, which corresponds to this x plus 3 term in the function. Well, the x plus 3 is to the first power, which means that the graph on each side is going to behave like 1 over x, which means we know that the tails need to go in opposite directions, right? Well, on the left-hand side, the graph goes straight down, which means on the right-hand side, it needs to go up. Okay, so from our intercept here, I have the graph going up. Okay, and I'm going to pause on the other side for a second on what happens here, because we need to actually look a little further right before we do that. So here we have our 0 at, let's see, x equals 3/2 or 1.5. And again, it's below the horizontal asymptote, so we know the graph is probably going to come up from there and go close to the asymptote. Something like that. And then again, if we look at the term corresponding to that 0 in the function, the 2x minus 3. Well, it's to the first power, which means, again, that the graph is going to go straight through that 0, right? So here it's going to come down and then just go along there. Sorry, that's poorly drawn, but it should go along the asymptote there, okay? All the way down. Now this allows us to figure out what's happening on the other side, because again, this vertical asymptote right here came from this term, x minus 1, which is to the first power, which means that the tails on each side of the asymptote need to go in opposite directions. So here on the right-hand side, it's going down, which means on the left-hand side, it needs to go up. Okay, and we get our picture that looks something like this. And now we're done. Good job, everybody. Okay, a couple of things I want to say about this. Number one, if either of these terms had been squared in the denominator, then that means that the tails on each side of the asymptote would have gone in the same direction. Okay, and there's an example like that on my PowerPoint you can go through and work on by yourselves. Similarly, if the powers on either of these things on top had been different, then the graphs would have behaved differently as they passed through the horizontal intercepts here. Okay, so we might have had some bounces or some flattening outs or something like that. So that's something to keep in mind. But again, kind of the process here is to identify all the asymptotes and intercepts and then use that information to draw your graph. Okay? One other thing that I'm not going to go through right now is actually doing the opposite. Okay, so going from the graph of a function to the equation. I would say in that case, what you want to do is identify all your vertical asymptotes and all your intercepts, and then use that information to figure out what goes on the top and bottom of your function. Also with those, just like with polynomials, you need to find the value of a, the coefficient that goes out front. So if you don't remember exactly what I'm talking about, look back at your notes on polynomials and you'll see something like that. Cool? All right, if you guys have any questions, please email me. Be available by email later today. And then also happy to answer email questions tomorrow. Hope you guys are having a great week. Look forward to seeing you all soon. Bye.